Hey everyone, and welcome back to Flutter from Scratch. In our last video, we got to see what changes were coming to the newer version of Flutter Block. We saw that there were some breaking changes unfortunately, but we also saw how these changes were ultimately for the better. Well, that's all good and well, but now let's imagine you've got a project that's using version 7 of Flutter Block, and you want to migrate it to version 8. Or possibly you're starting a new project, and you're using the new Flutter Block plugin, and you're wondering where your mapEventToState method and what these weird new on methods are. So what do we do about that? Well, we'll migrate a simple Flutter Block app from Flutter Block version 7 to version 8, so you can learn how to migrate your code by hand. Additionally, if you're just starting out with a new version of Flutter Block, you'll also learn how things used to happen and how they happen now. So let's get into it. So now what we'll do is we'll have a look at our sample project, and we'll look at what functions these buttons perform in our block project. So for starters, we have our long-running operation, which just invokes a future and then yields a response. And then we have our streamed operation, which yields a string over time to report its progress. Finally, we have another streamed operation that's largely the same as the example before it, but it uses a complex object or a class to give specific information on its progress. In this case, it's just toggling between two different types of icon. As we can see here in the Git log here, I have a commit from version 7 when it's working with Flutter Block 7, and then another commit for Flutter Block version 8. This commit I'm on now uses Flutter Block version 7 and just whatever version of Equatable that we can get, just so the package actually works. In my services here, I have a fake network service, and basically what this does is produces three different types of asynchronous operations. The first is just a future, which is something that will return after a period of time and emit one value. The second is a stream. It's a stream of type string. So normally you might see this if you had a long-running operation and you wanted to have status updates on how it was going over time. But if you only wanted to have text updates, like downloading a file, like 10% complete, 20% complete, that sort of thing. The third and final example we have here is a stream, when the type of stream is a complex stream response. When I say complex stream response, I just mean it's a class that you've defined yourself. So it's not a simple type like a string or an integer. What this looks like in Flutter Block 7 is it looks like this. We normally capture the event if it's to load the home, and we do something asynchronously in the background. In this case, we're not depending on anything, so we can just show it immediately. But if the event is to run a long-running event or to invoke our future from the fake network service, then we first yield to say that we're running an operation, and then we await on the response before finally yielding that response back up to the block, which in turn would update the UI. And that's pretty simple. You run a function, it takes an amount of time to complete, and then you yield that single value back up into that UI. The second type of asynchronous operation that we see here is when we're trying to access a stream and we're trying to unwrap the value of the stream and pass that into our block. We do the first thing here that we're used to, which is to yield immediately to say we're undertaking this operation. And then the next thing we do, we use this little yield star function. Now this is known as a yield generator function, and I'm not an expert on them. Basically, what they mean to me is that they take the value of the stream that we're specifying here, and then we try and yield the subsequent values from that stream back up into the stream that we're calling it from. Now in this case, because our stream type is home state and the type of this stream is string, we can't just yield it directly. We have to use the map function here to take every event that comes out of it and then yield it into our home loading state. And then after that's all done, we then yield the fact that our home has finished loaded and we put the user back to the main screen. The third and final example is the run long-running streamed complex event. This is really about the same as this example, but again, instead of using a simple type like a string, we're using a class that we specified ourselves. And again, we see this yield generator function, and we use the map function to then map those results into something that'll be compatible with the state of our block, before finally, again, yielding the home loaded state. These yield generator functions are something of a common bugbear for people who are coming to Flutter Block for the first time, but also for seasoned developers as well. I went over this a little bit in the other video, but basically, if your stream never completes or something bad happens, your block can just hang up indefinitely. They're not impossible to use, not by any means, but they are a little bit complicated to use, and I know it's something that I struggle with quite a bit. So, there's nothing really wrong with this code, with our block per se, but the use of the yield generator function here can get a little bit tricky to use, and it's one of the things that actually goes away when we change over to Flutter Block 8. So what I'll do is I'll go ahead and I'll open up our Git panel here, and I'll just change across to the Flutter Block V8 commit. It's worth noting that as part of this change, our service has stayed exactly the same. We shouldn't really need to change any of the way that our services work, because they should be completely abstracted away from how our block invokes them. But coming back to how our block works now, the first immediate change here is that we don't have a mapEventToState method anymore. Instead, we have these on events here that are set up in the constructor for the home block. It's a pretty substantial change, but just to get a handle on it, let's look at the simplest type of example here. When we have an event come in and we want to do no processing, no service invocation, nothing, we just want to emit a new state. And in this case, we're simply registering a type of event handler using the on method, and then we have the emit function here with the state that we'd like to emit. So that's pretty simple, right? We're taking on an event, we take that event, and then we emit a new state instead of yielding. We also notice that we're not actually yielding a stream of any type anymore. Instead, we're just emitting a new state. That's a big part of what I found to be the changes in the upgrade to Flutter Block 8. A second example here shows how we can handle a future. Again, we're just emitting the initial home loading state to say that we're doing something, and then we await the response of this call to this service. Again, this is pretty simple. It's just a function that waits for 3 seconds and then just returns a string. Once it's done that though, it emits the response, waits a couple more seconds, and then goes back to the initial home loaded state so we can click another button. It's pretty simple and not really different to how we used to do it in mapEventToState, just the fact that we're using emit now instead of the yield keyword. It gets a little bit more interesting and I think a little bit better when we start to look at how we handle our streams of type string. Now we know how we did this before with a map operator and a yield generator, but here we have on our long running streamed event, again our incoming event and the emit function which we can call, and immediately we emit to say that we're running the operation, and then we use the await for command. It's possible that await for is new to you. It's something that I think I've only ever seen in Dart up till now, but what we're doing is we're calling this stream and we're waiting for that stream to give us responses. Every time this stream gives us a response, we just call emit and we call the state and the result that we have. Then, when that stream completes of its own accord, we emit the home loaded state. So we can see here that we don't need to use a yield generator or the map function or anything like that. We instead can just call emit no matter where we are within the block to simply emit that new state. And as your app gets more complicated and your code gets more complicated, that'll really make your apps a lot easier to maintain and a lot easier to work on. Our third example here, again, is much the same as the second, but instead of using a string, we're using a complex object. And again, it's quite simple. We just use the await for method to wait for all the output of this stream to complete. As we get the responses, we emit those responses into the home loading state, before finally emitting the home loaded state. I really think this way of using the emit keyword instead of having a stream and yielding from that stream is a much better way to handle your code within these blocks, and its upgrade to Flutter Block 8 is really a change for the better. And hopefully you do too. So hopefully that gives you some idea on how to migrate your code, or start using Flutter Block 8 in your projects. There's obviously a lot more to Flutter Block than just knowing the on and emit methods. So for more advanced workloads, you can check out the documentation, or alternatively, join the Flutter Block Discord channel and ask some questions. The link to both of these things is in the video description. If you're struggling with a certain aspect of Flutter, let me know in the comments, and I'll see if I can take you through it from scratch. But for now, thanks so much for watching, and please like and subscribe if you found the video useful. Also, don't forget to follow our Instagram, where we cover smaller tips to do with Flutter.